This video is a continuation of our investigation into how one goes about running a case-based micro-simulation in Complexit. For those who may be stepping into this video without watching the previous, case-based micro-simulation is a ex-ante evaluation tool which allows you to explore various options, what-if scenarios, to make interventions on the cases and clusters that one has been studying. The real strength of Complexit is that you're moving across time in your analyses from looking at, again, this is the Welsh Multiple Deprivation Index, the key factors you're interested in, the cases that you're studying, and their particular profile for the set of factors you're examining, clustering those cases into their groupings of best fit, based on theory, current literature, or hunches or expertise, or simply exploring, using the SOM to corroborate that which is unsupervised learning, and then exploring with your database the outcome on the SOM map or SOM grid to look at the k-mean solution relative to the SOM solution. As we said then, the real strength is moving from that ex-post evaluation, which is after the fact, to an ex-ante evaluation, which is now looking before the future, looking at interventions or policy procedures that one might implement to make a difference on the cases one's been studying for the purposes of improving their relative well-being. In the previous video, what we were looking at was cluster 4, which is struggling with the highest levels of deprivation, as we see by re-looking at the SOM map and seeing that this quadrant, the cases and clusters in this quadrant are struggling the most as compared to these. The other unique thing that we pointed out about this approach to micro-simulation is that on this grid we have the actual cluster solution, as compared to this, which has all of the individual cases and their cluster membership, both in terms of the SOM saying it belongs to this cluster, quadrant 4, and also by k-means to this cluster 5 and this cluster 6. We cluster the clusters in the microsimulation to simplify, to allow basic interventions to be explored. And what we did in the case of this practice tutorial that was previous video was to see if we could make some type of systematic intervention across these key factors to begin to move this community towards a slightly less difficult situation. And if we remember, we looked at the prototypes, which are the factors, and we looked at the bar plots and saw the bar plots show us, in this case, the profiles for all the clusters, whether or not a case belongs to them. And the idea here was perhaps we could drive this from here over to here, which is slightly improving. What we did notice when we ran the intervention on for making an impact on income deprivation, employment deprivation, medical outcomes in terms of birth weight and mortality, slightly improving preparedness for graduation from school, and lowering violence a bit in the community, was that we were able to move the communities that belong to cluster 4 from here to here. And so that was considered a reasonably good success. At this point, however, what one has done in terms of doing that it's been about thinking that through and testing it at the level of an individual intervention. In agent-based modeling and a lot of micro simulations, though, one needs to have a slightly more robust sense of how often is that intervention that we did going to actually succeed. One has to take into consideration that these numbers are artifacts or traces of reality. 11.67 doesn't actually mean anything in the real world. 19.33 down to 19.21, again, what does that actually mean in the real world? It's hard to say. These are composite measures across a whole range of key factors. So we put into this a sensitivity analysis. And the sensitivity analysis allows us to then run hundreds to thousands of simulations exploring variations on the intervention we did to see how often that actually works as a way to just slightly increase the rigor of our intervention. You'll see here that I hit sensitivity and said there are no changes to the target cluster because I didn't pick the right one. The most important thing when you run your sensitivity analysis is to actually pick the cluster 1 explored. In this case, we moved cluster 4. Now we can click on the sensitivity analysis, and it'll allow us to explore the intervention we made. What you'll see are the variables that you actually changed. We changed income, employment, we changed educational preparedness, and we changed violence in this particular intervention, and we were able to get a shift. What this is basically allowing you to do then is to dither that intervention. So the intervention in this case was we decreased income deprivation by 27%. We decreased employment deprivation by 8.9%. We improved preparedness by 4.46%, and we decreased violence by 9.9%. However, most interventions will not be that exact, so one would like to potentially dither that, which one could think of as sort of a standard deviation around it. So what if we went from 27% down to 29 and up as far as 25 by making a 2% dithering? How often does that intervention hit? I'm not going to do that for all 4 because one of the most important things is when you're running a micro simulation, which is ostensibly a Monte Carlo simulation, a significant amount of time often is required for the machinery to run it. It could take minutes to hours to run. So when you hit this tab and you're sitting there waiting, don't be worried because it actually does oftentimes take time, because one's doing all various combinations of these 4 interventions based on the degree of dithering that one is doing. So we'll do a simple intervention. And one can see down here we get the sensitivity analysis results saying basically running this analysis through the 20 some variations made, possibilities, that 100% of the time it hit. It was a good intervention. We can, however, just slightly up that just to show some of the more complexity that's involved, and also dither the employment. One sees again that it's landing pretty well. 100% of the time, even with that level of dithering, we're getting success. One might think, though, however, that maybe one might want to push that a little bit more and dither these two to a degree of 4% to just say, well, actually, let's say we hit that employment, but really the change, even though we made a decrease in 8, what in reality if it was only came out 4 or potentially 12? Would that still succeed? What's the percentage of time? And we see that, interestingly enough, even with that dithering, we're still pretty confident that this is a reasonably good intervention that one could run. However, when we start to improve or increase the amount of dithering done, there's going to be more time. And so this will come up and show you sensitivity analysis currently running. May take several minutes or longer to do this because we're testing 4 attributes on 4 clusters. So we can dismiss that. And we see that, again, we're getting pretty good success for this particular intervention. As you do more complex interventions, however, it begins to tell you that the success rate will significantly go down. Oftentimes, the intervention might be 80% of the time success, 70% of the time success. And again, that is giving you good feedback on the level or quality of the intervention you're making. But one must always remember that this is a simulation, a simplified simulation, because it's looking at clusters to which a group of communities belong. For example, in cluster 4, if we look, cluster 4 is comprised of 3 different communities. Cluster 3, for example, is comprised of actually a rather large number of communities. So there are differences even within those clusters that one has to consider when thinking about the outcome of one's analysis, which is why it's always important to go back, for example, and look, here are the 3 cases in 4. Simple enough because it is just these 4. So we can feel reasonably confident that all 3 communities are in this area and that there's the potential to drive in the right direction. However, again, one would want to look at the differences within these communities, 18 to 12 versus 1, by going back to the original database and looking at those particular communities to see their particular unique instances to evaluate the overall quality of this intervention, in addition to your individual analysis, the running of the clusters, and the sensitivity analysis. But again, in a perfect world, we would have better information and be able to do the most sophisticated interventions possible. But given the real world in which we're in, this is a useful way to begin to help people think about their data and to think about the types of interventions they might make. And as we'll discuss later, all of this information in terms of statistical form and visual output is in the download report, which we'll talk about in the final video.